Hi everyone! Today I would like to talk about object-oriented programming. And object-oriented programming is very popular during last decades, but why is it so popular? Why is it so powerful? Behind object-oriented programming we have three concepts. They are encapsulation, inheritance, and polymorphism. And all three are important for object-oriented programming, but are they equally important? So let's try to understand it. And we will start from encapsulation. Encapsulation is about hiding the internal implementation of classes and making available for external use only externally shared methods or data. And if to think about encapsulation, it's like a car. In car, we have engine, we have gearbox, and all of the mechanical parts of a car, they are hidden from you being a driver. As a driver, you operate with a steering wheel, with accelerator, and other things that are kind of publicly available for you. And in object-oriented languages, this is usually achieved by public, private, or protected keywords. But is it a feature of object-oriented language only? So in procedural languages, for example, let's see, this was also quite achievable. You had encapsulations there because you could easily have modules and header files. So you would share the things that are publicly available in header files, and the other are private, kind of private. Moreover, we have other languages that have object-oriented features other than Java or C#. For example, Python. If we take Python, we don't have public or private keywords there. Instead, the encapsulation can be achieved using underscores, which is basically a naming convention. A naming convention is something you can basically use in each and every language. If you agree within your team that this underscore before the name is, let's say, a protected method. So definitely, encapsulation is not what is unique for object-oriented languages, and it's not that makes them really powerful. And the second concept is inheritance. In inheritance, we have is a relation. And is a relation is, for example, we have a car, and we have a sport car, and sport car is a car, so it can be inherited from a car if we are talking about classes, which is quite straightforward. The problem with inheritance is that it's usually not as straightforward as in the example of cars, because when we create complex business logic, the classes there are usually do not usually have so straightforward relations, and inheritance is often misused. And by the way, inheritance is a feature of object-oriented languages. We don't have something like this in procedural languages. So you can try to achieve inheritance there, but it's very tricky. And is definitely not something that comes for low costs there. The question is if inheritance is really so useful. I mean, of course, it's good to use inheritance where it's applicable. But you can see a mind that inheritance is kind of an anti-pattern even. And some authors, they share this idea. And they suggest to use composition over inheritance, which in many practical cases makes sense. Because if inheritance is wrongly used, which often happens in complex business logic, then at some moment when the base class is modified, all the child classes, they get influenced by this modification. So even in an example of a car and sport car, we can get into situations when we get into troubles, because if we have inheritance and a car, for example, has implementation of engine, and during some time it will work well, but at some moment we get electro cars, and electro cars can have two engines, and then we have to modify our parent class, but maybe non-sport cars, but some other cars, they cannot have electro engines, but they will be influenced by our modification. So in many cases, composition, so when a car and sport car will have engine inside, which will be passed through constructor, composition gives more flexibility. So inheritance is good. In some cases, it's very applicable, but it's not what makes object-oriented languages great. And the last thing is polymorphism. And polymorphism, it allows to have a notion of contract. Let's think about USB port. So your laptop has a USB port or maybe USB-C port, but what it gives a lot of flexibility to producers of devices, because USB port has a clear specification. And each and every producer, they wouldn't care about the laptop itself. They wouldn't care about the device that implements USB port. They care about specification of USB port. And they are independent from producers of laptops or other devices that have USB port inside. From the other side, producers of laptops are also independent from producers of devices, because they also have specification how USB port should work, and they will implement it regardless of what device can be plugged in. This power of having a kind of contract, a specification, or an interface, it's what is a natural feature of object-oriented language, and this is achieved by polymorphism. Whether it's interface or abstract class, is definitely not something that existed in procedural languages. And in procedural languages, something like this could be maybe achieved using function pointers or tables of function pointers, which is very, very bad way to go. It's not verified by compiler. It's very error prone, so it's not something you would like to use. From the other side, in object-oriented languages, interfaces or classes obviously are used very widely. And I have seen in large projects when there are libraries of interfaces, just library with interfaces, and other libraries would implement those interfaces, and some applications would depend on the library of interfaces, and the libraries that implement those interfaces would be plugged in on demand. For example, let's think about a storage. We can have an interface which defines a storage, which defines such method as store some data or read some data, but implementations of storage would be a database, and then it would be a file store, and it can be object store, anything else. But our applications that uses the storage, it would depend only on the interface. And from the other side, storage implementations would depend on the interface, which make the final implementations of both parties independent from one another. And this is the power of polymorphism, because in large projects, it gives us not tightly coupled modules or libraries, which allow us to replace them if needed. Even in situation when some library gets screwed, you can easily unplug it, create a new library, and plug it in instead of rewriting the whole application. So to sum up, all three concepts, of course, they are important, but they are not equally important. And what really gives the power to object-oriented languages, why object-oriented languages are so much used in large and complex projects with very complex business logic, is polymorphism. That's it for today. Thanks for listening, and bye-bye.